G'day! In this series of videos we are combining our Python and Psychopy programming with our Arduino programming because what we wanted to do, or what we would like to do, is to have some low-level hardware control over things like LED lights and sensors and servos and motors and whatever. And the way that we're going to do that is to use a microcontroller. In this case, we'll use the very common Arduino. In the previous video, we left off with a program that flashed on and off an LED light. And what you'll see is that we wrote that from scratch, but in the Arduino, when you download it, there is actually a set of examples. And as you can see, I've gone to File, Examples, go to Basics, go to Blink, and there's actually one that's pretty similar, almost exactly the same as what we built from scratch. Okay, and so the reason why I didn't use this example is because I wanted to go through the thought process of what we need to do to set up our Arduino before we actually get it to do something. Because if we don't know what we're doing and we just run ahead and do our experiment, if there is a problem or if something doesn't make sense when we're analyzing our data later, we've just blindly assumed that everything was set up correctly. And so that's why I've avoided using this Blink example. But anyway, so this example was written by Scott Fitzgerald in 2014. And you can see here, it's pretty much exactly the same. All sketches in Arduino will have a void setup and a void loop. In this case, they're using the built-in LED. So if I upload this to our microcontroller, to our Arduino, you'll see that it was successful. It says done uploading, but our LED light is no longer lit. But what you might notice is that the actual inbuilt LED, if I cover that up, okay, so that's turning on and off with the same duration. So if you don't have any LEDs, you can use the inbuilt LED. And I believe that's attached to pin 13. So you could set pin 13 as your output, or you can use LED underscore built in. All right, we'll go back to ours. So there's a lot of example programs actually in here. So have a look around. We'll go back to ours. So short to ground, the long leg to pin 12, because remember, diodes are unidirectional. You can force them to go the other way, but if you go past their breakdown voltage, all that sort of stuff, I'm glossing over a lot of things here. Anyway, our LED is back up and running. So we have a very simple control over our, essentially what we want to control, which is the lighting of our behavioural arena. What I'm going to do now is just extend this further. If you don't have any other LEDs, or you just want to leave it with just a simple LED plugged in like what we've got here, brilliant, that's fine, you leave it there. What I'm going to do now is introduce this bit of electronic circuitry, where what I have done is basically built, again, another quite simple circuit, because this Arduino can only supply so much current to drive so many things, and that's enough. So the Arduino can drive this single LED, no problems at all. But in our case, we have these ultra bright LED lights. I actually want to shine quite bright light into the arena, and that's going to require the use of these really quite energy hungry LED lights. To turn these guys on, in fact I want to probably turn on about 6 to 10 of them, that's going to be too much juice for what the Arduino can supply. So I'm having to use an external power supply and a switch. Essentially I'm using a transistor as a switch. So I've got 12 volts coming in from the wall here. So this 12 volts is then going into here. And then you'll see I've got this bit here. Okay, this is a voltage regulator. It's going to turn this 12 volts into 9 volts. So it's called a 7809 voltage regulator. Okay, quite common. And this here basically can accept any voltage up to, I think, about 30 volts-ish. But if you put 30 volts in, you're only going to get 9 volts out. But it's going to get really warm because it has to scrape off, essentially, or regulate, 21 volts. Okay, and that's going to be lost as heat. So that's why we've got this heat sink on the back. We're being quite gentle. It's only 12 volts in, 9 volts coming out. you'll see that after the voltage regulator here, we've got some circuitry here, a capacitor and a resistor and an LED. This is smoothing the output of the power supply, so we've got a really nice 9 volts and it's pretty stable. And I've got this red LED here because I want to make sure that when I've got 12 volts plugged in and it's charged up and everything's working, I can see what's going on. The reason why it's red, a red LED, is because we can see red, a mouse cannot see red. And so if I have this inside the laboratory, I'll put it in a glass case or something, then I can just look over and go, oh yep, the power supply is working, so everything should be good. You'll also notice here, I've got this sort of computer chip looking thing here. This is called a ULN2003A. It's basically, not to go into too much detail, but think of it as like a switch. Okay, it's a transistor switch. So I attach this side here. You can see I've got a lot of pins here. I attach the digital output pin from the Arduino to one of these. Okay, and then draw a line straight across the top. So draw a line straight across, and you'll see I've got these 2 black cables here, and these 2 are attached to the LEDs. We've got one here, and we've got another one here. Okay, let's see if I can make that look nice and clear for you. So I've got one going from here to here, and then the other one going from here to here. So I can attach 2 different pins, one to this LED and one to this LED. Now, where is the power coming from to drive these LEDs, these ultra bright LEDs? Well, that's coming from the 9 volt power supply here. Okay, and I've got it coming through 2 resistors. So here I've got some resistors, one resistor here and another resistor here, these 2 blue and white things. Okay, so essentially instead of coming straight out of the Arduino now, I'm going to basically connect the Arduino to this transistor switch, okay? And then that transistor switch will then switch the high voltage, the higher current power supply from this 9 volt regulator. Hopefully that should still be clear to you. So what we'll do is we'll take this out. I've got a cable here that I've created. This here is a pin. I'll just slot that into the pin 12 socket on the Arduino. You can see here I've got a little clamp here that I can clamp on. So here I go to pin 12, okay, and then I'll clamp that onto the left hand side of this top transistor. Okay, so this is I think about 7 or 8 transistors back to back to back, and each of them are isolated. So you get 7 switches in one basically. I've got a black cable here. This will go to ground. We've got a pin. We've got the spring loaded clip. So I'll put that into ground here, and then the ground is actually down here on the chip, right down there. And so you might ask yourself, well, why isn't it working? You've got it all hooked up. You've got the Arduino going to the positive. You've got the ground going to ground. Well, we now need to put in the 12 volts. So if I take this, so this is just coming from a wall wart that's plugged into the wall. I turn that on. There we go. You can now see that bright LED light. You might also be able to see, if I move this down here, that our power LED is also lit up. So that means that I've got at least 9 volts running to this side of the circuit board. This side of the circuit board down here obviously is then going to power your LED lights. Okay, so let us now add a second LED. So pin mode, we're going to go into digital pin 11 from the Arduino. I've got another cable here that I can connect up. Okay, this is also going to be an output pin. Okay, and what we're going to do is we'll do pretty much exactly the same thing. A digital write, pin 11, we'll send pin 11 high at about the same time as we send pin 12 high. Make sure to remember your semicolons, and then we'll go digital write, pin 11, low, comme ça, and then we'll upload it like that. You'll say, okay, so we've got one working, but the other one's not lit up. Why not? Well, we haven't attached pin 11 to the Arduino. Sorry, to our circuit. So I'll go pin 11 into the socket. Now I have to be a little bit more careful because this is quite a big bulldog clip, alligator clip, because I've got some ordered on Amazon of these smaller ones. We'll go bonk, like that, and here we go. We've got both LEDs lit up, and they're now addressable separately. If I send pin 12 high, okay, and then I go delay, let's say what I want to do is actually get them to switch. So I'll send that low, and then we'll send this high. So just play around. So you should see now one turn on and one turn off. There we go. All right. So this is a slightly more advanced output where we've used a transistor switch, we've used a regulated voltage power supply here. We have to be aware that the Arduino cannot drive too much current. We need to use something in between the Arduino and our output LEDs. In this case, it's going to be a transistor switch and the regulated voltage power supply coming out. So from now on, I will use this circuit, this electronic component, and we will now think about how we talk along the serial port to Python. We'll leave this video here, and I'll see you in the next video.